All right, y'all. I am recording this so that people can go back to this and watch it. But just to give you a little heads up, I'd like to start with something that I kind of touched base on last week when we did the non-calculator version, excuse me. So I'm going to share my screen here a second and just revisit real quick the Google Drive folder that has all this stuff in it. I am going to be spending time on this practice test calculator 1. So if you don't have this one pulled up, again, this is, let me go back to it here, the SAT practice test number 1 calculator version. Okay, that's what I'm going to talk about. And what I want to touch on first is on this first page here, and this is how it'll look in the SAT, by the way. It gives you these formulas. I know for today that this formula right here is actually going to come into play, but most of the rest of the stuff isn't even used on the SAT, at least not on the one that we're going to look at today. But it's there. So if you're like, man, I don't remember that formula, come back here and make sure you double check to see if the formula is here. Or just some minor details here, like this one actually is going to come into play. The sum of the measures of degrees of the angles of the triangle is 180. That's also a straight line. We're going to talk about that today. But in just a second, I'm going to go through all of these problems that maybe you have problems with first, and then I might pick some problems if I don't get enough to just go through as well. Other than that, that's what today is really going to be. Just another refresher. Today we're going to do practice test number 1, and there are solutions to this right here with explanations. That's from the SAT themselves. And then there's another one here that has my work on it, and that's the one I'm actually going to open up, and I already have it opened up, but this is the one I'm going to be looking at on the screen with you. Just as another kind of, hey, there's more here, you can look at, we've got a practice test for non-calculator stuff. We talked about that last week. There's more of the non-calculator part 1. There's also, let's see, some spliced together problems that I did with some solutions. There's another practice test number 2 non-calculator, and then some more practice problems here with some solutions as well. So there's a lot of different avenues that you can look at. I thought I had the chapter 4 calculator test on here as well. Maybe I'll try and get that together and get that on here as well. But lots of resources. Use this folder. There's lots of people in this folder. And then if you miss anything in the meeting, of course, you can just go to the videos of the sessions and it'll be on there. I think today's probably won't be linked until tomorrow, but it'll get there, okay? All right, so with that being said, this is where I want to start on this. What I'd like to do is just let me take like a minute. I'm going to go kind of silent for a minute and just give you an opportunity to look through this, and anything that you've circled, maybe just write those numbers down, because I want to go through those that you have issues with first before I start picking ones to go through. And I could go through this whole thing from front to back if you want, but I'd like to start again with the problems that maybe you have problems with. So I'm going to give you about like 30 seconds to a minute. Look at these problems real quick. If you haven't looked at them yet, maybe kind of just peek at them and just say, hey, I need to maybe see what that one is. Like I know for sure number 8 is probably something that I should go over. And as I look at it, there's some other ones that I think too, but I want to give you an opportunity. So again, 30 seconds to a minute, go pick out 5 or 10 problems that you would like to hear me go over. Go. All right. Problems? You guys got some numbers for me to go over?
I got some.
Go ahead, throw them at me.
19, 24,
24,
25,
25,
29,
29,
36.
36. Cool. Others from other people.
Can we do 8, 9, 11?
8, 9, and 11. Absolutely. Anybody else? Okay. So what I'd like to do is I'm going to actually kind of show you up here on the board behind me how to go through some of these problems. Last week I kind of just pointed at what to do and stuff, and I feel like we're probably better off if I actually show you on the board. So if somehow you can have that practice test open that we were looking at, right, as well as this screen so you can see what I'm doing, that'll probably be helpful. Now, if it's a problem that I don't think that I can talk about on the board, then I will do it. I'll just share my screen and we'll look at it from the practice test itself. But I'm going to start again in numerical order. Anybody have any other ones before I go through this? I'll probably do these 8 problems and then I'll probably pick like 4 or 5 other ones that I think probably wouldn't be bad for you to hear. All right, cool. So let's start on number 8. Okay, so I'm flipping over to the 3rd page of the document, and that was the one I knew I was going to have to go over this anyway. So here's what it says. Okay, let me grab a utensil here. Okay, I think you guys can see this pretty clearly because I'm seeing it pretty clearly on my end. But let me know if there's something you cannot see. So for number 8, make sure where I'm at here. Okay, good. It says for what value of n is the absolute value of n minus 1 plus 1 equal to 0? So I literally just wrote it out first, right? And then what some of you are going to want to do is try and start solving things. This is one of those things, and this is a big deal when it comes to SAT, is sometimes if they're giving you the answers, plug them in to see if it works, right? They give us 0. So remember, absolute value of every number is always positive, right? So if I plug 0 in here, this is A. If I plug 0 in here, I get 0 minus 1 plus 1, which is the absolute value of this. This right here is negative 1, but the absolute value of that is 1. And 1 plus 1, well, that doesn't equal 0. So it's not A, okay? I'm going to do the same thing. I'm going to try with B. B says 1, so I'm going to plug 1 in. 1 minus 1 plus 1. Well, 1 minus 1 is 0. The absolute value is 0. 0 plus 1 is 1. That doesn't give me 0, so that's not it either. So this is kind of like process of elimination, right? Like sometimes you don't know how to get the answer, but you can just go through and start eliminating things that you can. I just realized I still have this on, so don't mind me, okay? All right, so pop a color too. All right, so we've got 2 as well, right? Absolute value 2 minus 1 plus 1. This is 1, and the absolute value of 1 does not become negative. It's always positive. So really I get 1 plus 1, which doesn't equal 0 either. And so from process of elimination, it's D, right? None of the values they gave us. And more so, and I wrote this on the solutions, if you go and look at that, you can never, if I were to just solve this problem, and this is where a lot of you want to go, right? Is if I took this problem here and I minus 1 to both sides, right? Like pretend it was like just n plus 1. You would minus 1 to both sides. These cancel, and minus 1 is equal to negative 1. And I just got done saying the absolute value of every number is always positive. It's kind of an algebra 1 standard, right? So I'm never going to be able to take the absolute value of anything and get a negative number. So there's another way to kind of think about it, okay? All right, there's 8. Let's look at 9. So I'm on the next page now, okay? And on number 9, oh, this is kind of ugly, but maybe if you see me do it, it makes a little more sense. This is solving for a variable. And sometimes students have a hard time solving for variables because there's just too many things going on. So if I rewrite the problem for number 9, it says A equals 1052 plus 1.08t. Okay, and what it says in directions for number 9, like, first of all of the directions for number 9 and 10 are there, but in number 9 specifically, it says, which of the following expresses the air temperature, which in the directions above number 9 says that's T, in terms of the speed and sound of a wave. We actually had something like this on the non-calculated one last week too. So to solve, what that means is, we're trying to solve for this variable here. Look, if I gave you 3x plus 4 equals 9, you would all know what to do. You would minus 4, and then you would divide by 3, right? Well, it's the same steps here. It's just that there's letters here, so we can't combine stuff. So for instance, to solve for t, I got to get rid of this first. So I would subtract 1052. These will cancel. I get a minus 1052. You can't combine those, right? Equals this. Now again, if I gave you 3x equals 12, you would know to divide both sides by 3. It's the same thing here, right? It's just divide by 1.08 because I got to get rid of those so I get t by itself. And by doing that, I have to also, of course, divide this side by 1.08. And there's my answer. It's A. If you look at the choices there, t equals A minus 1052 divided by 1.08, going backwards, okay? Questions about this before I move on? Okay, cool. Let's go on to the next one then. All right, we've got, what was the next one? 11. Okay, all right, so same page on number 11. It says, which of the following is not a solution of 3x minus 5 is greater than or equal to 4x minus 3? And on the solutions that you can look at on the Google Drive, I solved it one way. What I was doing is I was plugging numbers in, right? I was plugging in -1, I was plugging in -2, I was plugging in -3, I was plugging in -5. But if you go about and you just solve this for x, right? If you remember, you bring x to one side and the numbers to the other side. So I'm gonna minus a 3x here. Those cancel. That's a 1x minus 3. Then I'm going to bring, so I had one thing cancel over here. You always need something to cancel on both sides. So I don't want to bring that 5 over because then I've got stuff I've got to still move. But if I bring this, excuse me, not this. If I bring this 3 over, like so, I get -2 is greater than or equal to 1x. Of course, I would divide, and I get this. So x is less than or equal to -2, right? Which I'm going to rewrite this. If I flip this around, right, see how it's pointing at x? So I needed to point at x with the equal sign. It's opening to -2. It's opening. This is telling me what numbers will work. All numbers that are less than -2, which if you think on a number line, -2, -3, -4, -1, 0. Where is it less? Well, it's here and that way. So if you look at the choices, -2 will work because it's less than or equal to. -3 will work. -5 will work. The one that won't work is -1. And that's what the question was asking, is which one is not a solution. If you don't get what this is, you can still just go back and plug numbers in. And that's what I was trying to show you. And maybe I will just put that real close to the screen. I mean, you can see it on yours, but I want to just kind of see if I can get this on there the way I want. Right? So on A, I just plug -1 in to the x's. I'm trying to do this backwards, right there and right there. So if I plug -1 in here, I get 3 times -1 is -3, minus 5 is -8. I get 4 times -1 is -4, minus 3 is -7, and -8 is not greater than -7. Whereas for all the rest of them, it did work. And I was looking again for the one that did not work. So kind of two different ways of looking at that problem. Okay. Questions about that? Okay, let's move on to, let's see, number 19 is the next one. Okay. Just got to get myself in order. I don't want to get myself all messed up here. So 19 says a food truck sells salads for $6.50 each. There's actually two ways to solve this one. I showed you one on the document using substitution, and I feel like that was way more confusing than what it needed to be. But go ahead and check out at some point, number 19. Go check out what I did for substitution. The first thing I want to do is I got to come up with formulas for this, okay? And the formulas, okay, if I say that X is salads, and that Y is drinks. And then I start looking at what does this stuff even saying, right? It's saying a food truck sells $6.50 for the salads and $2 for a drink. So $6.50 for a salad plus $2 for a drink. And then it says they have, let's see, the amount of money that they sold, their revenue from selling was $836.50. So money with money with money. Okay, you combine all those together. And then it says the truck's revenue from selling a total of 209 salads and drinks. Total. What does the word total mean, right? Like think about if I said I've got 5 apples and my friend has 4 apples, how many total apples would I have? Well, we'd add 5 plus 4. So total means add, right? So the total drinks and salads is just X plus Y. And they said it was exactly 209. Okay, now if you looked at my work online, it was probably a bit confusing. This is what it is. But after that, what I did is I used substitution. So I solved for X by moving Y over here, and then I plugged that in here. I think, especially if you've had me as a student, that the easiest way to do this is use elimination instead of substitution, right? When they're set up like this, if I just times this line by -2, right? I times everything by -2. Why did I pick -2? Because it's going to cancel with this 2. I could have times everything by -650, and I could have canceled x, but then I'm dealing with decimals and it gets a little gross, especially times 209, right? So I'm going to rewrite this. Let me see if I can. I'm just going to rewrite these equations. I get 650x plus $2y equals 836.50. When I times these by -2, I get -2x minus 2y equals -418. Right? And these will cancel. That's what we want. We want something to eliminate so I can solve for one variable. And the beautiful thing is here, it actually asks us to solve how many salads were due that day, right? How many salads. So when I can do subtract here, 650 minus 2x is 4x, right? It'd be plus a negative. Right here, I'd minus those, and I get $418.50. And then you just, oh, sorry, that's 450. I'm sorry. Let me not make that mistake. 450x. And then to solve this, you would just divide both sides by the number next to the variable. And it just so happens that when you get it, the answer is 93. And that's actually what we were trying to solve for, was the number of salads. If I wanted to know the number of drinks, well, then I would just take this and plug it in right here, right? Minus it to the other side, and I would have got the 116? That wasn't the answer, though. I wanted the salads. That's how I can find the salads, okay? Questions about that? There's a lot to that. So part of it is being able to put the words into mathematical sentences, right? And that's what a lot of this is, especially in the calculator version, okay? All right. Unless there's any other questions, I'm going to move on. Let's see. 24 is next. 24. All right, there it is. 24 is really gross, guys. And it's going to be even worse if you had geometry a long time ago, because it's probably been a while since you remember some of these terms, right? So like it says, which of the following equations is the equation of a circle? You know what? I'm going to go and look at that SAT. Did they give you, just a second, do they give you the formula for the area of a circle? I'm going to look at it here. They give you the formula for the area of a circle, but they don't give you the equation for a circle. No, they don't. Okay, so sorry, I just want to double check that before I just give this to you. So from my memory, I remember that the equation for a circle is x minus x1 squared plus y minus y1 squared equals the radius squared. That is not a formula SAT is giving you, but that is the formula for the equation of a circle, okay? Now, if I use this, which I'm going to for number 24, okay, it tells me that I have a center at 0, 4, and that I have an endpoint with a radius of, and it's telling me the endpoint radius, which is kind of gross, right? But really what that is that's giving me 2 points. That's giving me, I'm going to kind of show you this, that's giving me, for this, we'll call it x1, y1, and for this one, we'll call it x2, y2. So the first thing I'm going to do is I'm going to use the distance formula to find the radius, right? I know that if it has a center of 0, 4, that this is 0 and this is 4. So my equation right off the bat is x squared plus y minus 4 squared equals, well, r squared, okay? And again, that's because it says center of 0, 4, and that center is my x1, y1. That always, always, always works that way. To find the radius, well, let's look at this picture, okay? From here out is the radius, right? Well, it's telling me the center is at 0, 4, and that the other point is at, this one right here on the circle, is at 4/3, 5. That's kind of a pain, but to find this distance, we're going to use the distance formula. Maybe you remember this from geometry, maybe you don't, but the distance formula says the square root, and I have this written on the SAT practice test that I have online too, okay? So I'm just kind of rehashing this. It's x1 minus x2 squared plus y1 minus y2 squared. Okay, you can switch these up. It doesn't really matter because once you square them. But when I use these 2 points, this 0, 4, so that was my x1, y1. This is my x2, y2. And I plug them in here. I'm going to have 0 minus 4/3, which is just negative 4/3 squared, plus 4 minus 5, which is negative 1 squared. Again, just using the y values, which is, I'm just going to keep going here, which is a negative times a negative would make that positive. 4 squared is 16, 3 squared is 9, plus, well, this negative 1 squared means that, which is 1. But I can't add 69s plus 1. I need a common denominator to do that. So I just made 9 ninths be 1, right? Because once I have a common denominator, well, check it out. I can just add the tops, right? So I get the square root of 25 over 9. Okay. Now to square root that, well, you square root the top, 5. You square root the bottom, 3. Now here's the problem. That's the radius. That's the radius. It's 5/3. But that's not what we have to put here. We have to put 5/3 and then square it. So really, it was even before I got to here. That's how I got 25 ninths as the radius for that problem. That is a lot of work, guys. That's one of those problems that unless you know the distance formula and the area of a circle, you might just make an educated guess. So at least if I'm looking at this problem, 24, and if you can see it on here, at least I know that I can rule out 2 problems. I can rule out B because it doesn't have a minus sign, it has a plus sign. And I can rule out D for the same reason. So at least I know it's either A or C, right? And from there, without knowing some of these formulas, it's going to be kind of hard to do, just to be honest with you, okay? But at least you can use process of elimination and know that I had to have a minus sign here, so it can't be excuse me, C or D. Okay. Questions about that one? There's a lot to that one.
Yeah, I have a question.
Go ahead.
So, with knowing that there's a minus sign there, in the answer, is that because that minus is in the equation for the circle?
Mm-hmm. Yes. Go ahead.
Also, on top of that, when you use the distance formula, it doesn't matter what order you put the x and y in.
Correct. Because let me just pick normal numbers like 0 and 2, right? If I go 2 minus 0, I get 2, and I square it, I get 4. If I go 0 minus 2, I get negative 2, but when I square negative 2, I still get 4. So you're right, the order of these does not matter because when I square it, it's going to become positive no matter what. Good question. And then for these, yeah, because I know that's minus signs, if this was, let me take a step back, if the radius was started the center at 0, negative 4, then I would have had minus and negative here, and that would have become a plus sign. Okay. Let me see something. I think I got something from the chat too.
Thank you.
Yep, no problem. Anybody else? Okay, let me keep going here. Then the next problem is 25, right after it. Okay, so give me a second here. So again, this is 25, okay? And really, I think I did this problem harder than you need to. Like when I go through this, it says, after approximately how many seconds will the ball hit the ground, right? So I would have a height of 0, right? It says height equals, and negative 4.9 t squared plus 25 t, okay? Because this is a calculator version, if you're familiar with graphing calculators and you have an access to a graphing calculator for this, this is actually something you can do really easily on the calculator by just plugging this in and then going and finding the zeros. If you haven't done that before, I don't want to teach you that now. But if you know how to do that, or if you go here and you're like, I don't remember how to do this, come find me. I'll show you how, okay? But with that being said, we can still solve this problem like this. And here's the thing. If I give you an easier problem, okay, if I give you 4x squared plus 3x equals 0, and I said to solve that, what you would do is take out the GCF. You would take out an x out of both, and you get 4x because I divide that by x and I divide that by x, plus 3 equals 0. And then you would set x equal to 0, and you set 4x plus 3 equal to 0, and you would solve it. Okay, so similarly, I'm going to do that to this problem that we have now. Right? I'm going to take a t out of both of these. If this was a 5, I could take a 5 as well. But otherwise, there's no number that goes into both of those. But I can take a t out, okay? And what I did on the quiz is I did not take, or excuse me, on this form, is I did not take a negative out, but I could. You don't have to. So if I take a t out of here and I divide that by t, I'm left with negative 4.9 t, because the 2 would cancel with that. If I divide that by t, I'm left with a plus 25. And now, again, the way that zeros work is when you have factors like this, you set each factor, so this one, t equals 0, there's one answer. The other answer is setting this factor equal to 0, so negative 4.9t plus 25 equals 0, and solving that for 0, which is really 2 steps, minus 25 to both sides. Negative 4.9t equals negative 25, and then divide by the number next to the variable, right? I feel like we're doing a lot of this kind of stuff on this SAT, right? We're doing a lot of solving by moving stuff over and dividing, like a lot of stuff like that, right? So these cancel. What you get when you divide these out is a little more than 5. It was like 5.102. And the question says, after approximately how many seconds? Well, that's pretty close to 5 seconds. That's why the answer is 5. Okay. Questions about that one? Okay. Let's move on to 29 then. Let's see. So that's 29. Okay. For 29, so it says for a polynomial p of x, the value of p of 3 is telling me p3 is negative 2. Okay. Which of the following must be true? And this is really just knowing the remainder theorem. Like literally, if x minus 5 is a factor, that would mean that p of 5 would be 0. That's what it means to have a factor. It means you have no remainder. It means you have a 0. If x minus 2 was a factor, that would mean p of 2 was 0. This is for A. This is for B. For C, if x plus 2 was a factor, that means p of negative 2 would be 0. And this doesn't say any of that. That's why it's D. And by definition, the remainder theorem is synthetic division. Maybe some of you have seen this. I know if you had me, you have. But synthetic division was this thing where I'm making up numbers, so I don't know if it'll work. But you would drop it low on the first one. You would times and add, times and add, times and add. This number right here is your remainder. It's what this is, right? It looks like this. So this would literally be p of negative 2 equals negative 12. It's a remainder theorem problem. So if you just know that if I plug in an x, the number I get here is the remainder, that's why it's D. Really, there's not a whole lot more I can tell you there besides the fact that that is literally by definition what the remainder theorem says. When you plug something in, what you get as the solution is your remainder when you were doing it synthetically. Or dividing longhand, which is even grosser. You don't want to see that. Okay. All right, so that leads me to, any questions about that? Okay, that leads me to 36. And then, like I said, I think we're getting close to this half-hour mark, but I don't mind going a little long today. Actually, we're already over a half hour, but I don't mind going a little further so I can go over more problems you want, or I can just maybe start from the beginning and say, hey, we should look at these. 36 says, oh, okay, 36 says, for what value of x is the function h above undefined? And the only thing, when you're dealing with a fraction, the only thing with fractions that you cannot have is something divided by 0. If you were to plug in 2 divided by your 0 in your calculator, it'll say undefined or cannot divide by 0 or something along those lines. It would not give you an answer. Now, if you went 0 divided by 2, well, that's just 0. We can do that. But you can't divide by 0. So in this problem, when I have 1 over, let's see, x minus 5 squared plus 4 times x minus 5 plus 4, okay? What I know is that this cannot be 0. So to find where it's undefined, I'm literally just going to set this equal to 0. And so when I did that, I FOILed this out. This is x minus 5 times x minus 5 plus, I'm going to distribute that, 4x minus 20 plus 4. This factors, if you remember FOIL, x squared minus 5x minus 5x plus 25 because of the negative times a negative. Put that in there, not the smiley face. And then I still get this plus 4x minus 20 plus 4. I still know this is equal to 0. Okay, this is still, there's a lot going on here, but you got to just combine like terms. Negative 5x is negative 10x, plus 4 is a negative 6x. Looks like the x squared just comes over here. And then plus 25 minus 20 would be 5, plus 4 would be 9, right? So when I do this, if I'm trying to find the zeros, just like we were actually talking about earlier, it is factor and set those factors equal to 0. So this factors to x and x. The factors of this are 3 and 3 or 1 and 9, right? But if you recognize this, this is a difference of squares, or this is a, excuse me, no, there's not a name. I don't want to go there. So I know 3 and 3 is going to give me 9. I know to get that 6x, right, I go 3x here, I go 3x here. To get that negative 6x, they both have to be negative. So do those signs, right? However you factor, there's multiple ways here. Some people have used X box is something that you can use. Some people use guess and check. There's something called the AC method that I teach sometimes. But the key is here, I have this, and what I want, again, is to have the zeros. So I set each of these equal to 0. X minus 3 equals 0. X minus 3 equals 0. Obviously, you're going to get the same answer for both of these by just adding 3. So you get x equals 3. This is called a double root, not something you probably have to do on the SAT. But that's the value, 3. That won't work. Look, we can check it, right? And really, I could have done this from the very beginning. If I just plug 3 in here, 3 minus 5. Matter of fact, let me show you. I'm going to rewrite it over here. 1 over. If I plug in 3 in here, I'm going to get 3 minus 5, which is negative 2, and negative 2 squared is 4. If I plug in, again, 3 in here, 3 minus 5 is negative 2 times the 4 is a negative 8, plus 4 gives me negative 4 plus 4, which is 0. And again, I can't have 0 in the denominator, so that showed me that it worked. Now, it seems like this would be a really lengthy problem to try 1, to try 2, to try 3, to try 4, and then maybe even try some negative numbers. So it might not be your best bet, but if you have time and you can't figure out how to do it this way, just keep plugging in numbers into that bottom part until you get 0, okay? Just another kind of test-taking strategy, okay? That's all the problems that you guys gave me to go over, but I'm definitely willing to go through some more. Is there anything else that, as we were looking at this, people, you were like, man, I don't know what I'm doing on that. Something else I can go over?
Yeah, I actually have another one, but I also have a question about this one too.
Sure, go ahead.
So you were talking about kind of just plugging in numbers with this problem if you forget how to do it or get confused. Are there like any numbers that you shouldn't plug in? Like that would be like too ridiculous, I guess. Like any numbers that you should favorably plug in, I guess.
Yeah, no, that's a really good idea. I think that the first thing when I see this, the first thing I would think of is trying to plug in 5, because I know that 5 minus 5 is 0. So I'm going to get some zeros here. In fact, I'm going to get a 0 here too, but I still have plus 4, so that doesn't work, right? I know that if I'm thinking about this, I would probably think about 0 to plug in, and I get 0 minus 5 is 25. I get negative 20 plus 4. Then I know I'm close. It was 1 though. It wasn't going to be 0. So that's why I was trying to say it's more of a time factor thing. I don't think that there's really something I can tell you to say, try this for sure, besides the numbers that maybe you can look at and would give you 0. But there's no like real like, hey, you should try like 1, 2, and 3 first. I'm going to tell you because this is on the part that is handwritten. This isn't like an A, B, C, D. They're probably going to give you a number that's real nice to be able to plug in. So I would try whole numbers, I guess, as a first guess. But this is at the end of it. You're probably going to be pretty fried by the question 36, to be honest with you, after having taken reading, math, all day. So maybe, just try your best guess to plug in there, or you got to start distributing and kind of combining like terms and going from there. And then really, once you get to here, if you don't remember what to factor from there, from here, it's a little easier to plug in like 1, or to plug in 2, or to plug in 3 and see which one works from there. Maybe a little easier than all of this plugging in. Okay. Good question. I answered you. Go ahead. Keep going.
I also have another problem that I was confused about.
Yeah.
Problem 28.
28, for sure. Let me go look for it here. Okay, yep, 28. It's a graphing problem. And inequalities are a graph and shade type of thing. So let me put it up here. So as I'm sketching this graph, right? As I sketch my graph, and I look at y is greater than or equal to 2x plus 1. So that starts at 1. And hopefully you guys remember how to graph. You'd go up 2, right 1. It'd be like this, up 2, right 1. It'd be a line that looks like this. Okay, and then I want to figure out which way I got to shade this, right? So what I'm doing, I've got y is greater than 2x plus 1, is I want to test this point 0, 0. If that point works, then I shade towards 0. If it doesn't work, then I shade away from 0. So I plug 0, again, this is 0, 0. I plug that into my x and my y, and I get 0 is greater than 2 times 0 plus 1, which is 1. And 0 is not greater than 1. That is a false statement. So that means this is not in the solution. So I would shade in this direction up here. Okay? All right. I feel like I got to get another color here. Just a second. All right. So for the other line, it says y is greater than, well, I don't know if you can see that. I hope you can see that. Is greater than 1/2 x minus 1. So I'm going to start at -1 right here, okay? And I'm going to go up 1, right 2. So it's going to be somewhere over here, right? It's going to be a graph that's going to kind of come like this, right? I feel like I just did something wrong. No, we're good. Okay, then I plug in 0, 0. I get 0 is greater than 0 minus 1, which is -1. That is a true statement. So that means for the green line, 0, 0 is part of the solution, so I need to shade that whole line towards it. So all up here. Okay. But the solution to these problems is the double shaded region. It's where it's multi-shaded. So you can see there's only one shading in here, so none of this matters. If I were to keep going with this line, it would go like this, but none of this matters either, because it's where it's double shaded, which is this stuff here, and this stuff here, and then all of that stuff up there, right? So the question says, which quadrant contains no solutions to this system? Well, look, there's some points in the first quadrant that work, a lot of points in the second quadrant. If you remember, this is 1, 2, 3, 4 for quadrants. There's some in the third, but there aren't any in the fourth. Yes, the green line had some in the fourth. It would have been like all this stuff, but it's not part of the solution because the solution has to be where they're both shaded. That was a good one. That's actually one I probably would have went over even without you. Anybody else? Questions on anything before I maybe pick a few? We're going on about 40 minutes. We're doing okay. Okay. I think I might have circled a few that I think I want to go over, and I don't think they're on the first page. Let me check it out here. Or the second page, or the third page. We already went over the one I wanted. Bear with me a second. I'm kind of talking to myself here. No. Statistics. No. Maybe number 18 a second. Number 18. Okay, so if I look at 18, I haven't done that one yet. Nope, I have that. Okay. Because I think 18 is one that you can see how to do. Where it says y is less than -x plus a, and y is greater than x plus b. And it tells us that 0, 0 is a solution. So remember earlier how if 0, 0 is a solution, I just plug it in, right? So that means that if I plug it in here, right, 0 in here and 0 in here, that's going to give me 0 is less than a. Okay. If I plug it in here, again in x and y, I'm going to get 0 is greater than b, right? If I rewrite this and that, so I'm going to put 0 less than a, this I can flip around. I can say b and 0. And again, it's pointing at b, so I need it to point at b. Well, look, I can put that here, right? Okay, so what does that mean? B is less than 0, A is greater than 0. So A is a positive number, B is a negative number. That's the first thing we look at, right? But more than that, B is less than A. Like that's from this, it has to happen, right? So if B is less than A, then I can flip this around again, A and B. Again, it points at B, it points at B, and that is selection A of your multiple choice. Okay. Let's see if I can find another one that I know that you could probably stand to hear. Ooh, 21. Yeah, I want to talk about 21. Let me look and see if there's another one here first. So if you're not there, maybe flip over to 21. And then I want to talk maybe about 23 as well. And then I'll see if there are any other questions, and then we might kind of call it there. Okay, so let's look at 21 here. And I think actually I'm going to have to switch to the share screen method because there's too much going on at 21 for me to show you up on the board. So hang out a second. Let me share my screen here. All right, so I'm going down again to number 21. Let's see here. All right, right here. Okay, so this is obviously a statistics problem. Okay, and what it says here is we've got this data in this table for people who dreamed and stuff, people who can recall their dreams at least once a week, right? And so this is the column of the people who cannot recall any of their dreams. Okay, this would be a really fun one to actually do with a class. But group X consisted of 100 people. You can see that total. So did group Y, right? And then if a person is chosen at random from those who recalled at least one dream. So think about it. When I look at this table, how many people recalled at least one dream? It wasn't in this category. These were the none, right? But these recalled at least one dream, right? They recalled 1 to 4. But so are these, right? The 5 or more is at least 1, right? So what is the probability that a person belonged to group Y? Well, if I look at, I've kind of tried to lay it out here, but of all the people who recalled 1 or more dreams, that's adding all 4 of these columns together. And that's why I was trying to show you down here the total of at least 1 to 4 or 5 or more, where I added 11 plus 68 plus 28 plus 57, is because all of these, the totals don't matter right now. These totals don't matter right now. It's within the table. These 4 are the ones that recalled 1 or more a week. So that is my total. And then if they belong to group Y, it would just be these 2 numbers right here, just 11 and 68, because these are group X. I'm not worried about that. So I added 11 and 68. That's how I got 79. And then the total, again, is all 4 of these together. That's how I got the 164 to get C as my answer. Okay. Any questions about that one? I think 23 is going to act the same way. So I want to be able to show you on here, not on the board. And I did something a little different to solve mine that I will show you on the board. But look at what it's saying for 23. Of the following, which program's ratio of its 2007 budget to its 2010 budget, so we're looking at this column 2007 compared to this column 2010, is the closest to the human resources program ratio between those two? So the first thing I wanted to do is go to human resources and find the ratio between this and this. And I tried to kind of show it here, but I don't really like how I did it. So what I'd like to say is if I just divide this 4 million number by this 5 million number, I get 0.684. I did this on my own earlier, but I get 0.684. So what I really want to do is just take all of these, so the agriculture, the education, the highway transportation, and the public safety, and just divide 2007 by 2010. And when I do that for A, so for agriculture, I get 0.766 when I divided those 2 numbers. For B, for education, I divided this 2 million number by this 3 million number, and I got 0.719, which is pretty close to that other number, but it's not quite there. When I divided the highway transportation, so this 1 million by this, I got 0.828, which is way high. And when I divided public safety, so this number again here, divided by this number, I got 0.568, so way too low. So really it was between A and B, and A again, the number we want to get close to was like 0.69. A was 0.71. A was 0.76. B was 0.71. That was the one that was closest. You can kind of see in my work that I was trying to compare the ratios themselves, and like 2.2 to 3 was closer to 2 to 3 than the rest of these, 3 to 4, 5 to 6. It was the closest one. But again, if you just divided them and just compare their decimal values, that was what I thought was another way to solve this. Okay. Anybody else want to go over any other problems? Because at this point, I'm not sure where else to go.
I had another question, which was
Sure.
the problem right before that. I solved it wrong, so I was wondering how you solved it.
Sure. Let me go back to it again. I'm sorry, what number was it again?
22.
22, thank you, okay. So on 22, which of the following is the best rate of change? Oh, rate of change is slope. So it's literally like, if you remember, I'm gonna show you on the board here in a minute, because this is something I can show. Okay, so it's a slope problem, and if you remember, I think most of you, if you really think about it, probably remember that slope is y2 minus y1 over x2 minus x1, and this slope is the same thing as rate of change. They actually, by definition, are the same exact thing. The slope is the rate of change of a graph. So when it asks on number 22, what's the average rate of change for agricultural and to natural resources from 2008 to 2010. So my first point is 2008, comma something. My second point is 2010, comma something. And I'm getting the information right from the table, right? So the, where am I at here? So agricultural is in 2008 is 358,708, and in 2010 it's 488,106. And now it's just a matter of plugging in to find the slope, right? So on bottom, I'm going to get 2010 divided by 2008, which of course is just 2. On top, I'm going to go the 488,106 minus 358,708, which I didn't write that number down, whatever's on top there when I subtract there. But I know that when I divided it, I don't know, I'm just going to look at it. I'm going to say it's about 130,000. It's close, but it's not quite that. But when I divide it, I get 65,000. Actually, when I divided it exactly, I got 64,699. That's pretty close to 65,000 in terms of what are your choices here. 50,000, 65,000, 75,000, 130. This would be the closest to it, would be the 65,000. Did I answer your question, Jonathan?
Yes.
Great, cool. Anybody else, anything else? Okay. So remember the resources you have available to you, okay? I know that this SAT is coming. Like for my students, we're taking it next week already. So if you are looking at some of this stuff and you just need a quick explanation, shoot me an email. Maybe we can figure out a time to meet on Zoom and I can go over a few problems like this with you. There's only a week, so I really don't mind being available on Zoom. We can set something up that works out for both of our time. But again, if you have any questions on any of these problems or any of the other examples that I gave you on that Google Drive there's all sorts of stuff to do there. Shoot me an email. I guess for those of you who don't have me, my email, it should be there, but I will just write it up here. And you are welcome to write it down too. Okay, it's my first initial J, SIERSMA at Holland Public Schools with an S.org. Okay. So if you're looking at this stuff maybe this weekend, I'm a little less likely to get at you right away on a weekend, but I'll probably see it fairly decent timing, and then we can set something up, and I don't even mind doing that on the weekend sometimes. So other than that, unless you guys got any more questions, I don't have anything else planned for this. It was supposed to be a half hour and we're already approaching almost an hour. So, and again, totally okay with that. I'm glad that we got to talk about the problems we did. Any other questions about anything SAT related?
Is there another practice on Thursday or like another meeting?
No,
or is
that
this-
was last Thursday.
Oh.
But it was taped. And if you go to, Lily, I think that was you. If you go to the Google Drive, hold on a second. I'm just going to share my screen a minute just to show you guys. If you go to this Google Drive here that everybody was put into, and go to the videos of the sessions, you can see the ones that were done for the reading, the first two reading sections. This is the one that I did last Thursday on the one without a calculator, and then this is the one for today that we will link later on once we get this video taken care of. Anybody else? Okay. Thanks for coming, guys. Let me know if, again, you got any questions, get at me, and I will respond appropriately. Have a good one. Bye.
Thank you.
Yeah, no problem. Thank you for coming.
Thank you.
No problem. Thank you, Jonathan, for so many questions.